Assalamualaikum and good evening to everyone. My name is Muhammad Abdullah from RY32 Robotic and Automation. So today I would like to present about smart quality control and sorting conveyor line. This is our mini project. So this is our team member Shahrin, myself, Iqbal and Izzat. So today I would like to present about introduction. The introduction about our project is a high precision conveyor system designed to protect fragile, static sensitive PCB while maintaining seamless production flow through automatic grouping and inspection. Stage 1, intelligent grouping. Incoming board are counted and batched automatically to optimize downstream processing cycle. The time synchronized transfer. PLC manage timer coordinate precise transfer between conveyor segment, preventing collision. The stage 3 is quality inspection and sorting. Integrated defect sensor isolate faulty board in real time, ensuring only good unit advance. The problem is the manual risk mechanical fragility. Manual handling lead to circuit cracking and damage delicate component. The human touch introduce static discharge, causing invisible electronic failure. Inspection fatigue. Manual testing is slow and prone to miss defect, affecting final product quality. So the solution is PLC automated solution. The safe precision. Robotic arm move board with vacuum gripper, ensuring zero physical. The consistency. Automated sensor and testing station detect defect with 100% reliability. The process intelligent. Real-time PLC tracking ensure accurate batch counting and eliminate human error. And that's all from me. Thank you.
Warahmatullahi wabarakatuh. My name is Ahmad Syarif Aika Kamarudin. My matric number is 2313617636. I will present about objective for the project. Our main objective is to design a fully automated handling and inspection system for PCB that minimize direct human contact to ensure high product quality and significantly reduce waste by integrating smart sensor. By the system ensures consistent and accurate defect detection without slowing down the packaging stage. Furthermore, we implement an automated counting and tracking solution along the conveyor line to reliably monitor product flow, minimize product loss, and deliver highly efficient daily operational data. Next is system design and variable mapping. To transition this objective into reality, we configure our hardware input and output through Siemens Teleporter. The design utilizes a series of standard Boolean input, such as our start or stop buttons, photoelectric product sensor, and defect detection proximity sensors, map map it to specific PLC memory addresses. On the output side, we have mapped the motor drive for conveyor 1 and conveyor 2, indicator lamp, and the pneumatic actuators for boost and the pusher and reject cylinders. We have also integrated dedicated system timers and batch counters to manage batch tracking from 0 to 5, and total production counts up to 10. Next is a sequential function chart (FPC). This sequential function chart illustrates the step-by-step operational logic and state transitions of our automation process. The sequence initiates upon pressing the start button, which activates conveyor 1 until a batch count of 5 items is reached. Once the initial batching criteria is fulfilled, the process moves through precise time delays to engage the pusher cylinder, bridging the product over the conveyor 2. The system then batches into decision matrix based on the defect inspection result. Good product proceeds down the main line to be recorded by the finished product counter, while defective product immediately trigger the reject sequence before reaching the final stage. Next is overflow operation charts. Finally, for workflow operation charts break down the exact network execution sequence utilized within our leader logic program. Each is establish our system master run flag bit percent %n to 0.0 and details our timer T1, T2, and T3. Rhythmically, step the physical hardware through batching, pushing, and inspection zone. The logic continuously scan for manual stop override for all the final batch completion target of 10 finished item via counter 2. When the target is achieved, memory bit percent M31.1 if active is active, automatically halting all conveyor lines and cylinders to conclude a safe, reliable, and entirely automatic production cycle.
Alright, Assalamualaikum. My name is Izzat Ikhwan bin Rizam. My number matrix is 2313611723. So this is our project, which is PLC mini project. We use 2 conveyor. So this project is for to separate and detect which one is good product and defect product. So first I will start the push start button. It has 3-second startup delay. So here's 3-second delay, and then the conveyor 1 and indicator lamp will on. So after that, this is the sensor for the first conveyor. So we must have 5 product first in the first conveyor. Okay, after that, the pusher cylinder will push the 5 product to second conveyor. And after that, we have 2-second delay. So after the 2-second delay, for the pusher cylinder, and then conveyor 1 and indicator 1 will stop. After that, the conveyor 2 will on and indicator lamp 2 will on. So this is the defect sensor for conveyor 2. So if defect sensor detect defect product, it will trigger the reject cylinder and reject buzzer. Okay, and then here is for the finished product. So we put here if it achieve 10 finished product, the system will stop. All of the system, including conveyor 1 and conveyor 2. And it also reset the counter. Right, conveyor 2 stop. Conveyor 1 stop.
Assalamualaikum. My name is Muhammad Iqbal bin Mahadi. My matrix number is 231361733. Today I will present about my part, which is challenges and solutions. So the first challenging is fragility challenges. Every industry have a standard heavy pneumatic force can easily crack thin PCB industry subtractors or even stress fragile surface mount parts during high speed stage transfers in conveyor. So the second challenges is collision challenges. Incorrect transit timing creates conveyor, makes it piles up, binding optical sensors, and jamming sequential, which is a worst part, conveyor automation loops. So each challenges has been the solutions. So the solution firstly is system solution, motorized geared arm, utilize a velocity asynchronous arm that perfectly matches conveyor speed, makes it allowing bots to smoothly glide between conveyor belts without impact. The second solution is PLC solutions, a three-timer logic control employs sequenced sequenced logic across networks 3 to 5, triggers a 3-second buffer wait before the pusher initiates, followed by a 2-second safe port gap control. So the next part is safety requirements. So firstly is physical and electrical safety. The cylinder and conveyor have been protected by covers, chain, and roller cords to prevent injury for workers. Meanwhile, a brake wire touch stop button and air release valve actuates immediately when the emergency button is pressed to prevent the cylinder from moving suddenly. Second part is the logical safety and error detection. The machine only moves for the safety of the operator. Interlocking system has been used of simultaneous movement between the conveyor and the push cylinder will stop and sound an alarm if the sensor does not detect the product within in the set time after 3 seconds warning. Okay, the final parts is conclusion. So the firstly is manual risk elimination. This risk has been reduced successfully, protect fragile circuits from structural damage and ESG static failure by replacing human operator with speed synchronized, which is speed controller, touch-free mechanical handling system. So the second, consistent quality assurance. This quality ensures 100% production yields accuracy with automated optical sorting, immediate pneumatic scrap rejection, and also an autonomous full system shutdown upon final target completion. At the same time, it's full safety when it works. So the final is PLC process precision. It is coordinates flawless batch grouping, having a pneumatic transfers and cascade timing delays on a Siemens S7 1215 PLC types, resolving potential physical collision and line jams after the operational. So that's all from us. Thank you.